Who says a technologically advanced alien must resemble us exactly? The divergent evolution. One of the primary schools of thinking in modern astrobiology is that intelligent life from other planets would resemble us greatly in many aspects, especially when considering higher levels of organization. This is due to the assumption that the processes that give rise to life function independently of their surroundings, as well as the fact that physics severely restricts the range of alternatives that are physically possible. The likelihood that intelligent life is evolving elsewhere in the universe may therefore be very high, notwithstanding the possibility that it may not be of the humanoid variety. The fact is, we don't really know much. For instance, we don't know if life has emerged elsewhere in the universe or if Earth was the lucky winner of a cosmic lottery. Even if an extraterrestrial civilization existed, we are unsure if it would adhere to the same set of principles that govern the one planet that can unquestionably support life. There is no question that the cosmos is governed by physical and chemical laws, but there is less assurance regarding biological laws. Actually, we might not even be able to recognize life if we came across it on a different planet. In other words, our initial encounter with smart aliens could be damaging to our sense of self-worth, since we may be dealing with an intelligent species that is superior to our own. The aliens might be so foreign from us that they won't even be aware that we are sentient, so if that first contact does occur, we should be ready for another surprise. At first glance, it appears insanely hard to try to fathom what a technologically advanced extraterrestrial would look like physically. For starters, we are unsure of the existence of sentient alien people, let alone what their home planet or form might be. As a result, our task is restricted to utilizing what we already know about the development of sentient life on Earth, taking into account potential distant planetary settings, and making a number of logical assumptions. The two views. There are two conflicting points of view regarding the likelihood of intelligent alien life. Some people, on the other hand, have a more humanistic perspective on ET and think that it would essentially resemble a human, with 2 arms, 2 legs, a head perched atop the body, and the primary sensory organs situated on the head. The organism would unavoidably have taken an entirely different evolutionary path from that of humans and would have emerged in a planetary environment quite different from Earth. On the other hand, some exobiologists think that sentient ET could manifest in a radically alien form. The anthropomorphic view. Many scientists hold the opinion that extraterrestrial life may not be all that dissimilar from our own, and they frequently use the well-known occurrence of convergent evolution to support this claim. In essence, animals exposed to similar environmental forces tend to evolve anatomical traits through natural selection that are similar. This explains why a dolphin's appearance is comparable to that of a shark, a cartilaginous creature. Even an extraterrestrial organism that evolved and thrived in its liquid ocean would presumably develop a fish-like shape to move rapidly. The principles of physics apply equally here and on the other side of the galaxy, after all. The development of organic matter based on carbon compounds on Earth originated in an aquatic environment, and supporters of the humanoid form argue that discussion regarding ET morphology must take this into account. The trait of bilateral symmetry in body shape, which would dictate the future form of Earth's inhabitants, was initially developed by sea organisms. Its form minimized resistance and turbulence in the water, was the feature of all marine creatures, then spread to terrestrial animals. It was also the most economical in terms of genetic programming. Supporters of the humanoid form contend that intelligence, in the sense that it is linked to tool usage, can only develop as an evolutionary adaptation in terrestrial creatures. Due to the density and viscosity of water, it would be incredibly challenging for marine organisms to employ tools. Moreover, it appears that intellect can only develop in predators. How about bird life? There are some that are incredibly intelligent, like the crow, for instance. But, in order to create tools and evolve a sophisticated type of intelligence, an alien in the shape of a bird would need to have appendages like ours, fingers, arms, and hands. It is obviously impossible for an animal whose top limbs are used for flight. In order for an ET to reach intelligence, the evolution of legs, arms, and grabbing appendages is a delicate process. Basic tools and weapons, such as clubs, spears, knives, and bow tendons, must be held and used with a certain amount of dexterity in order to use primitive technology. However, all of this must be combined with quick movement, otherwise, our ET runs the danger of never being able to take a spacecraft around the galaxy and staying stuck in their comfort zone for all time. While debating the morphology of sentient ET, one of the most contentious topics is the number of limbs. Our forelimbs result from genetic inheritance from our earliest mammalian ancestors, who in turn received them from four-finned fish that migrated to land. Is there, however, a perfect number of limbs? To establish a surface plane, 3 points are geometrically necessary for strictly mechanical reasons. 2 points only constitute a line. A single limb, on the other hand, would obviously be entirely worthless. ETs that attempt to stand on just 1 or 2 levers will immediately tumble to the ground. Only because of our huge feet, which offer numerous points of contact with the ground, are we able to stand erect. Yet, without fingers or toes, at least 3 legs are required. Can tripod aliens exist? No, contend conventional biologists. In order to maintain its planar support base, a 3-legged creature must elevate at least 1 limb off the ground, which results in a statically unstable and dynamically dangerous scenario. From an engineering perspective, 4-legged animals make more sense since they can maintain balance even when 1 leg is moving. Should all limbs have evolved in pairs as ancestral fish could only have pairs of fins? Xenobiologists do not share this opinion. Dynamic 3-point stability is likely not required for most running bipeds and quadrupeds since they often keep 2 or fewer limbs on the ground. It's not necessary for terrestrial life to have developed from fish with even fins. A starfish's offspring, for instance, can have an odd number of legs. For large, intelligent animals, more than 4 legs are also possible. The prehensile tail of monkeys and the flexible trunk of elephants are only 2 examples of unusual appendages that are frequently used for extremely specific functions. Superior multipedia depends on neural control. Adding an additional leg requires significantly less brain circuitry than, say, adding an additional eye. Whereas eyes require millions of new neurons, muscles just need thousands. Aliens are considerably more likely to have extra arms than extra eyes or ears because roughly 1/3 of the mammalian brain is devoted to sensory tasks and only a small portion is devoted to motor control. As we previously established, the only reason terrestrial vertebrates have 4 limbs is because they are descended from 4-finned fish. We might currently be hexapods or even heptapods if we had descended from Euthycanthus, a Devonian fish with no less than 7 pairs of fins. After all, having 6 legs has a lot of benefits. Hexapods are an effective approach to distribute mechanical stress and lower the danger of bone fractures on worlds with high gravity. For 4-legged humans, injury or limb loss is more disastrous than for 6-legged ones who have spare limbs. Hexapods can maintain a steady supporting tripod on the ground even at fast speeds, unlike quadrupeds, which helps them balance better. Also, coordinating all those legs shouldn't be too challenging. In short, conventional scientists assert that the principle of evolutionary convergence rules over all life, and there appears to be no way to overthrow it. The issue is that these exotic forms, while they may exist and may be the most prevalent, are not evolutionary feasible nor able to explain how they might have developed technical intelligence without even the most fundamental manipulation abilities. Exotic biology. But given all the factors that could come into play, such as environmental factors, such as the planet-specific geological, atmospheric, and meteorological conformation, physical factors, chiefly the force of gravity, which is different from Earth's, and planetary factors, such as a habitable planet C, many scientists contend that there is very little chance that an alien life form could even vaguely resemble us. The idea that extraterrestrial life may be dependent on chemistry that does not require the carbon atom is one that more extreme exobiologists frequently raise. Although silicon, which is abundant in sand and especially utilized to create electronic circuits, is thought to be the building block of biological life, carbon chemistry is unquestionably the best chemistry on Earth. This might have an impact on how extraterrestrial bodies are constructed, since they might need different kinds of proteins, enzymes, nucleic acids, and other biological building blocks. An alien, for instance, might have extremely thick skin that is resistant to radiation, or a totally different circulatory system that carries nutrition and oxygen throughout the body. Carl Sagan, a renowned astronomer, was convinced in the 1960s and 1970s that technologically advanced creatures may emerge indifferently on land, in the sea, or in the air, with inconceivable chemistries, shapes, sizes, colors, appendages, and opinions. This then had an impact on science fiction of the time, which started to envision non-humanoid or even distinctly exotic life forms, such as sentient interstellar gas clouds with diameters thousands of kilometers, or strange balloon-shaped creatures floating in Jupiter's gas belts, using a hydrogen-based metabolism rather than an oxygen-based one. Some speculate that intelligent alien life may resemble insects, birds, fish, or even plants. They might resemble sticky jellyfish, like the heptapod organisms suggested in the film Arrivals, have a spherical appearance, or perhaps be a planet-sized ocean intelligence like the one in Stanislaw Lem's novel Solaris. However, traditional biologists scratch their heads and wonder, how could these creatures have become intelligent? They seem to us to be only fanciful hypotheses, without the slightest relation to physical and biological laws. To which, exobiologists respond that if the goal is to scientifically hypothesize intelligent alien life forms, then it is necessary to abandon all anthropocentric preconceptions and accept creatures that differ from us in every parameter. What do you think? And which group do you support? The exobiologists or the old biologists? Let us know in the comment.